My name is Karen Wilson, and I will be presenting to you all the concept maps for membranes. So, to start off, I want to categorize these things as having to do with the cellular membrane. So here we have the plasma membrane, which is the outer membrane made up of two layers and is embedded with proteins. Then we have the phospholipid bilayer, which is a membrane that consists of two layers of phospholipids. And on the side there, I put the sandwich model and the fluid Massic model, which are two models basically distinguishing ways of how to describe the phospholipid bilayer. Coming off of the phospholipid bilayer is something called the hydrophilic head. This is a part of the membrane that is considered attracted to water, and its counterpart is the hydrophobic head, which is a part of the membrane that is considered resistant if water is present in its environment. So coming off of hydrophilic, I put osmosis because when thinking of water, you think hydrophilic because it's attracted to water. So osmosis is the movement of water, and connected to that is simple diffusion, which is the spread of molecules within its environment. So the state of process of widely being spread. Over here, coming off of plasma membrane, we have gated ion channel, and that's a transmembrane that allows the flux of ions to pass under defined circumstances. So coming off of that, we have the membrane channel, and basically what that does is allows water and inorganic ions to pass through. And that brings us to the ion channel, which is a pore that forms in the membrane to guide the flow of ions across the cellular membrane. With that being said, you have something called selective permeability, and this basically determines what gets to enter or not. So it's a discrimination by the cell membrane, and it allows items to be transported. It has that decision. Alright, so we have hypertonic solution. This is a solution that leads to shrinkage in an environment. It's a solution that causes water loss, and I put it on the left side because you usually think negative when it's on the left side. Then you have an isotonic solution, which is a solution that does not affect the water pressure of an environment. So I use the word balance to describe it. Then it's also in the middle because, like on a pH scale, 7 is neutral, isotonic is neutral. Then we have hypotonic. When I think hypotonic, I think of hippo because it enlarges things that are inside of the solution. It's a solution that causes water to move inside of its environment. So coming down here, we have saturated fatty acids, which is what you do not want to eat. Saturated fatty acids contains no unsaturated linkages between carbon atoms, while unsaturated fatty acids, the good things, are carbon atoms in the hydrocarbon chain and are joined by double or triple bonds. Coming off of saturated, we have glycolipids, glycoproteins. In between there, I put detergent. For some reason, I thought of food when I put these together. So detergent molecule, when you think detergent, you think cleaning. So it's an agent which purifies or cleanses. Over here, we have steroids. Steroids is what you think of when you go to the gym, and that's exactly what it is. It's a family of chemical substances that includes hormone, body constituents, and drugs for enhancements. Then you have vesicles. Like I said, when I created this, I was thinking of food, things that you intake. So a vesicle is a small bladder or a sac containing liquids. Alright, so here I based all of these things off of proteins within the cell membrane. So you have your peripheral membrane, and that is it's a biological membrane with which it's associated. So this protein is temporarily attached, and the integral membrane is a protein that's permanently attached to the biological membrane. Coming off of that, you have the membrane proteins, which is a protein that interacts with or is a part of the biological membrane. I have the anchor membrane coming off of that, and that's a protein on the cell membrane that is covalently attached to lipids. Then you have a protein attached membrane, and the reason I added that on there is because all of these things are attached to the membrane. So this is attached protein through weak non-covalent interactions. Coming off of the membrane proteins, you have the receptor membrane protein. It acts in the cell as a signaling by receiving or binding to extracellular membranes. Molecules. Then you have the monolayer associated membrane, and that interacts with the inner layer of the lipid bilayer. Off of that, you have the lipid linked membrane, and that's interaction with lipids of the bilayer through covalent bonds. So I put all of those together because they interact with lipids. Alright, thank you for watching. Once again, this is Karen Wilson. I am in cellular biology.